we came out in the field, we went through the individual boxes in this kit to make sure we had ample supplies of chemicals, make sure there were no broken test tubes. So that's just a nice practice to get into before you go out in the field. Check your equipment, make sure you have everything you need. That's really a frustrating aspect when you get out here and you realize you can't do what you need to do because you don't have enough chemicals or you have a broken test tube for a particular kit. So again, I'm going to start with dissolved oxygen. This tends to be the most lengthy test just because you have to fix the sample and then you have to titrate different chemicals. Essentially for dissolved oxygen, but also for all the test kits in here, it's designed so that you look for a color change, and that color change corresponds with a particular end result. So it may indicate for dissolved oxygen how many parts per million dissolved oxygen are present. For pH, it'll determine where on the pH scale does that water fall. So with dissolved oxygen, we have a test kit with lots of different chemicals. So the first thing I have to do, this is the test tube or the test bottle that I'm going to actually use to collect the water. This is the only one that you have to do this with, but when you collect dissolved oxygen, you have to fill the bottle up with water and cap it underwater. The reason for that is if you fill it up with water and bring it up to the surface and cap it, you are inadvertently introducing oxygen to your sample and your results will not be as accurate. Will it be way off? Probably not, but the idea is to be as accurate as possible. So that's what I'm going to demonstrate for you now. Again, we're staying close to the bank. If you look further up this way, this is where we're going to be collecting the organisms for our macroinvertebrates. So we're very close to where all of our samples will be taken. So what I'm going to do is I'm going to come out here with any test tube or bottle or sample bottle that you're going to use to collect water. What you want to do is submerge it, get a little bit of water in there and kind of dump it out. The reason for that is there didn't look like there was any residual chemicals in here or anything that was left behind from the last time we used this, but I can't tell for sure. So doing that kind of takes away that possibility of error. So now I'm going to put it underwater and I'm going to wait for the bubbles to stop, and while it's underwater, and I didn't get all the air out. Hold on. There we go. All right. So now I'm ready to bring it up to the side of the bank and put the chemicals in and wait for the color change. This one is a little bit more involved, so we'll probably speed up the process for you as we go along. And there's nothing wrong with when you are out here in the field having the instructions beside you. That's what I have here. I've done this dissolved oxygen test for probably more years than you've been alive. But it's always helpful because, especially with this one, there are so many different types of chemicals you have to put in. I don't want to goof up, okay? And I'm trying to keep that from falling. Well, okay. So the first step here is to add 8 drops of manganese sulfate solution. I wasn't kidding when I said that there's a lot of chemicals in here. The one thing to keep, I'll stay down here. The one thing to keep in mind is when I capped it underwater, even though it was full at the time when I capped it, there's a piece in the cap that displaces just enough water for you to add these chemicals. So on first glance, you're probably going to think that's not going to fit in there, but it actually does. Okay, so you'll be able to see the color change throughout this process, and again, that's what we're looking for. We're looking for the color indicates what level we have. So I'm going to add 8 drops. Okay. And then I need to add 8 drops of the alkaline potassium iodide. And it looks like it's really full. Now when I cap it, it probably is going to displace some of this. That's okay. And now I want to cap and mix it. That's pretty good. And so you'll notice it's like a yellow-orange color. There's going to be precipitate in here, or solid material that's going to sink to the bottom, and so that's what we're going to wait for. We have to wait for it to settle to the bottom. You'll know that it's fully settled when you see the precipitate at the bottom and the rest of the sample is clear. So until we see that, we kind of have to wait around for that to happen. So stay tuned on that. Alright, so as you can see, the precipitate has settled all to the bottom. The rest of the water sample is clear. So now we know it's time to move on to the next phase. So the next item on the instruction list is to add 8 drops of sulfuric acid. This is very corrosive, so you have to be very careful. The reason for using sulfuric acid is it is breaking down the precipitate. So what we did in that first step, waiting for the precipitate to settle, that's known as fixing the sample. So we fixed the dissolved oxygen that is present in the water. And by doing that now, when we uncap it, we're not introducing extra dissolved oxygen. That oxygen that's in the air is not able to react with this. So what I've done, I've added the sulfuric acid, and I'm just kind of shaking it up, make sure it gets distributed evenly. And we have to wait for the precipitate to dissolve, which it pretty much has. But you can see there's a definite color change, but there's no precipitate in here. Now, if you look closely, there may be some small flecks floating around, and that's okay. We can move on with the test. What it's asking you to do is wait till the precipitate that was here in the bottom completely dissolves, which it has. All right, so now that our sample is fixed, now we're going to add it to our test tube. So we don't need all of this for our sample. We're only going to add 20 milliliters into this bottle, or into this tube here. And I'm just going to put it back in the kit so it's a little bit easier for me to handle until I get this uncapped. But that's the nice thing with these kits too. It has a place for you to kind of hold everything when you're on site. So I want to add it up to 20 milliliters to the 20 milliliter line. And this, you do need to be precise with this. You can't say, that's close enough, that's good enough. It needs to be right up to the line. If you go over, you have to pour some out and add a little bit more until you get it in there. And there we go. And now that larger bottle, we're pretty much done with that. That's done. That has served its purpose. That's all we needed it for. I'm putting the cap back on here because we're going to be titrating. So we're going to be adding another chemical to this, and we're going to, again, wait for that color change so that we can determine how much dissolved oxygen is there. So here's our titrator, and we're going to use the sodium thiosulfate. And there is a hole in the bottle so that you can put the syringe in, and you just want to draw it all the way out. You want to make sure that there are no air bubbles in here. If you get air bubbles, suppress it and start over, which is not a problem. It happens to everybody, but you want to make sure that you get it all the way back to 0, which means we have our titrator full. All right. Now this is the reason for the hole in the test tube, because we're going to add this chemical and we're going to add it slowly. We don't want to depress the entire syringe because we won't get an accurate reading that way. What we're doing is we're going to add, just push a few drops in at a time and swirl it. You don't have to take this out. You're not shaking it up. You're just putting a few drops in and swirling it. And we want to make sure that this color changes to a pale yellow. So and you'll know when it happens. That's why you have to do it a few drops at a time, because it can happen very quickly and then you can over titrate. So we're just going to add a few drops at a time and swirl it around. Okay, it's gotten a little lighter, but not a lot. So we need it to be pale yellow. when you're out in the field, it's really helpful if you have natural sunlight versus doing it in a classroom with fluorescent lights. The fluorescent lights make it a little bit harder to see. And as you can see, it's a pale yellow, but I'm going to add just a couple more, I think, and that's pretty pale. Okay, so that is a pale yellow. We're going to take this out. We're not getting rid of this. We're placing this off to the side carefully. And now we're going to add a starch indicator. We're adding 8 drops. 8 drops is the magic number for this kit. So and you'll be able to see a definite change. As soon as I get the cap on, I need to swirl it around to introduce it. So now we do not have a pale yellow anymore. We have sort of a purplish, bluish color. We're going to take our titrator and continue titrating until there is no color left. Again, this can happen very quickly. So we don't want to add too much at one time. You can add a few drops, swirl it around. Again, you don't have to take the titrator out. And it's almost there. So maybe 1 more, 2 more drops. Or 1 more. Because I can still see a little tinge of color. Now it's colorless. This is the result that we want. We wanted to see it colorless. Now, how do I use this to determine how much dissolved oxygen is in there? How much I use out of here is how many parts per million dissolved oxygen we have in the water. So right now, I used 5.5. So that means where I took this sample, the dissolved oxygen is 5.5 parts per million. We'll talk about what that means momentarily.